Okay, last chapter. Next week you will take final. Final question from chapter 9, 10, 11, 12. 9, 10, 11, 12. Using practice problems I gave you and answer on blackboard, right? So try to practice again, and then based on my answer. So, for example, a hypothesis test, you should answer hypothesis, then test statistic, critical value, and test result like reject or do not reject, right? And conclusion. So you should answer like this for a hypothesis test. And after chapter 9 is confidence interval. That case answer should like this, right? Something low boundary, upper boundary. If that is confidence interval for the mean, then mean, mu. If there is a proportion, then pi, right? And what else? So when you answer carefully answer, required answer, okay? Then chapter 9 confidence interval. Like this. Okay. Chapter 9, 10, 11, 12. Chapter 12, analysis of variance and regression analysis. I'm not sure. Maybe other instructors don't cover this part, but I like to cover this part. Always when I teach statistics, I cover this ANOVA and regression. Before I came to Troy University, I worked for a certain Minnesota State University, and after I left the school, I came here, and then one former student from Minnesota emailed me. Then the student asked me, "Did we cover ANOVA?" Yes, we did. So I sent lecture notes and then syllabus when I used it at Minnesota. The student emailed me, if we didn't cover this part, and then the student went to graduate school. Then graduate school asked the student, did you take statistics? And then if you take, then if the instructor covered ANOVA. If ANOVA was not covered, you should take another course, statistic course like that. So I covered, and then the student save money and time. Anyway, ANOVA, analysis of variance. Hypothesis test. Chapter 10, one sample test. If we have one sample, then using that sample, we test population, right? Two sample test. Either from one population, two samples, or each different population, two samples from each different. Two sample test, right? Okay, if we have three or more samples, three sample test, four sample test. If there are three or more samples, then we use this analysis of variance, ANOVA test. Okay. Simultaneous comparison of several population means. So three or more samples, then we use ANOVA test. Okay. When we test one sample, two samples, then we use Z or T, right? Depending on population standard deviation is known or unknown, right? ANOVA test, F test, using F distribution. F distribution looks like this. Longer right tail, y skewed, right? And then the value of the F distribution always positive, from 0 to infinite. And then the maximum is unlimited, infinite, so go forever. K of this F distribution, high, low, wide, and so on, depending on df, degree of freedom. There are two df, df1, df2, df1, df2. Higher df, high, lower df, low. There are two degree of freedom. First one is we call a numerator or df1. Second one is df2 or denominator. This is the F distribution table. Just showing you. On top, degrees of freedom for the numerator df1 and df2. So depending on. So finding this one also kind of a hypothesis test. 3 or more samples. This is hypothesis test. The same hypothesis, test statistic, critical value, test the result, conclusion, the same. So from table we can get critical value with df1 and df2. Okay. One way on analysis of variance. If we test 3 or more sample with one characteristic or variable. Okay. One characteristic gender, right? Maybe another characteristic like height, weight, something like that. Use only one variable. Gender, not both. Only one single characteristic or variable. Then we use one-way ANOVA or one-factor ANOVA. If we use two variables, gender and height, something like that, two factors or two-way ANOVA. Okay. I say always we need two values for test, hypothesis test. First one is test statistic. Second one is critical value, right? Test statistic usually from formula. Critical value from chart, right? Test statistic for F test, F equals MSA over MSW, MSA over MSW, very complicated. MSA is mean square among groups, MSW is mean square within groups. MSA on top, SSA divided by C minus 1. SSA is sum of squares among groups. That is sum of x bar, mean of x, sample, minus double bar means mean of mean, and square, something complicated, right? By the way, C minus 1, C is how many sample or groups. If there are 3 samples, C equals 3. If there are 4, C equals 4. And then the bottom one, denominator, MSW equals SSW divided by N minus C. SSW is sum of squares within groups. Sum of each sample minus sample mean and square. Here N is total sample size. N is total sample size. That is, if there are 4 groups, then C equals 4, right? Then each sample or group has 5 members. 4 times 5, total sample size is 20, right? So in that case, N equals 20 minus C, 4. Okay, ANOVA test. Hypothesis test always start with state hypothesis, right? For ANOVA test, hypothesis H0, mean first one, mean second one, and so on. If there are 4 groups or 4 samples, then mu1 equals mu2 equals mu3 equals mu4. So test if they are the same. For example, there are 4 Walmarts. There, like that. Then they test if 4 Walmarts sales are the same. Any difference? Like this. And then H1, not all, means, can write means over mu as are equal. So just be careful how many groups. There are 3 up to 3, 4, 4, 5, 5, and so on like this. And then critical value, the test statistic MSA over MSW, this one. The critical value from F distribution, critical value from F distribution with df1 and df2. df1 is C minus 1, C minus 1. If there are 4 groups, C minus 1 is 4 minus 1, 3. We call that df1 or numerator. And then df2, n minus c. N minus c. If there are 20, there are 4, 26, df2 or denominator. And then this one says F statistic greater than critical value, then reject. There is no. F distribution looks like this, right longer tail, right skewed. Critical value here, if critical value here, if F test statistic greater than critical value, reject, inside less than, do not reject. Okay, example. Okay, if we use formula, then calculation is kind of forever. So we will use megastat. So please be ready, megastat. Then open this file, chapter 12 data file. Option. Go. Browse. If you cannot see, then change all file. Then there's the okay. Okay, megastat available. Okay. Okay, first one, this one is example. Group 1, 2, 3, 4. So there are 4 groups. mu1, mu2, mu3, mu4, and not all means are equal. Says 0.05. Determine whether any significant differences exist in the strength of parachute woven from synthetic fibers from the different suppliers with alpha equals 0.05. Okay, megastat. Click megastat. And then here, analysis of variance. Of variance. Move cursor on analysis of variance, then one factor ANOVA, randomized, two factor, and so on. Single factor, so one factor ANOVA. Click one factor ANOVA. Okay, this one asks specify input range. Do you know how to, right?
Select the
click scroll from first one to the last one, and click and then scroll up to here and then release, then specify like this. Okay, then click and okay. Got it?
so when P is less than 0.5,
Excuse me?
it says when P is less than 0.5.
Which one?
I already did it, but when we went to annual,
Okay.
it says when P is less than 0.5.
It doesn't matter.
Okay.
Okay. Okay. Here, after running one factor ANOVA, then this one produce output like this, then it says ANOVA table. Okay? ANOVA table, a little bit different, but like this. Degree of freedom, first one C minus 1 and minus C. This one is DF1, DF2, right? DF1, DF2. Then SSA, SSW. MSA is SSW divided by C minus 1, DF1. MSW is SSW divided by N minus C, degree of freedom 2, denominator. F test statistic is MSA divided by MSW. This one is F test statistic. From output, ANOVA table, this is SSA, SSSW, DF1, DF2, MSA, MSW, right? And then F test statistic is MSA divided by MSW. This one is test statistic for this ANOVA test. Okay, so test statistic for this test is F equals 3.46. Okay, now we need critical value. From a table, if you have a textbook, you can use textbook table, but we can find critical value using megastat. Click megastat again, then probability, megastat probability, then this test is F test, right?
Mhm.
So F distribution, go down and click F distribution. Okay. First box, alpha. The question asks 0.05. 0.05 is default. And then DF1 and DF2. DF1 is C minus 1. DF2 is N minus C. But ANOVA table shows DF1 and DF2. DF1 is 3, DF2 is 16. 3 and 16. Good? Then click OK. When DF1 3, when DF2 16, critical value is 3.24. F equals 3.24. Okay. Critical value is 3.24. Test statistic 3.46. Slightly outside. So test result. Test result. Reject.
Yeah.
Reject the null hypothesis H0. So this is not true. H1 is true, right? So conclusion. There is difference, right?
You don't have to say like there is evidence or something. You just say there
You
is
can say there is evidence or something like that, or just from the question here, it says the question was determine whether any significance. So difference is true, right? The question, the difference is true, right? So you can say there is evidence that significant difference exists in the strength and so on, right? If
That's all really about the question. What the question.
yeah, so always repeat the question. If there is evidence difference, then there is evidence. If the test result do not reject, then H0 is true, right? That case, this is not true. There is no evidence. Something different, right?
So this one would say no evidence.
This one?
You said it is.
It is.
It
Okay,
is.
reject.
Because there is the something different, right? So there is evidence that difference, right?
I got you.
Any question? Okay. And, This problem number 1. So study but number 1. Okay. Number 1. Yeah, it's attached. This one I'll show you. Bring up this one. Ch012 is a frequent traveler between Los Angeles and San Francisco. For the past month, he wrote down the flight times on 3 different airlines. The results are like this. And then use the 0.05 significance level. And the 6 steps. The step is right. Then question: if there is a difference, in the mean flight times among the 3 airlines, okay, there are 3 samples groups ANOVA test, right? So this data is this one, right? 3 airlines. Okay, ANOVA test. Before that, we need hypothesis, right? One, two, three, right? Because there are 3 groups, there are 3 samples. mu1 equals mu2 equals mu3, and then not all mu's or means are equal. Good? And then, using this data, megastat, analysis variance 1 factor ANOVA, megastat, analysis variance 1 factor ANOVA, then click specify. Okay, when you specify input range for this megastat, it doesn't matter include label or not, but including label is better. Output shows the label. So click OK. Okay, ANOVA table here, right? So F statistics
3.04.
3.04. Now we need critical value, so click megastat again, and probability, megastat, probability, and F distribution.
Whenever you write the test statistic and critical value, do you have to put F equals?
F, because it's F test.
So
Okay.
if you just put like 3.04, is that wrong?
If your answer without f equals 3.04 is right, then I don't check. It's okay. But sometimes t-test and z-test. But student didn't indicate
Right,
z or t. Then sometimes student, it should be a z-test, but student do t-test. Then wrong, right? That
You wanna
case,
know why they got it wrong.
mhm. So alpha equals 0.05, and then df1, 2, because it's 2, right? df1 is 2, df2 is 32. So 2 and 32. And click OK. When df1 is 2, df2 is 32, critical value is 3.29. 3.29 critical value, 0.29, test statistic 3.04 inside, right? So, test result, do not reject. The null hypothesis H0. Okay, conclusion. This is true.
There's no evidence.
There is no evidence because there is no difference or equal. So we can repeat. There is no evidence that, and then copy this one. There is a difference in the mean flight times among the three airlines. Sometimes students answer like this. There is no evidence that like this. Then it's wrong, okay? Don't be lazy, okay?
See above question.
At least.
That's better than nothing. At least you're like, oh, okay, we'll look up here.
You know, so don't do that like that, okay? Write everything. Okay. Any question? It's easy. ANOVA test, right? So three or more samples, then ANOVA test. Always you need hypothesis. If there are 3, mu1, mu2, mu3. If there are 4, 1, 2, 3, 4, right? And H1 always the same, not all means are equal. Then test the statistic, critical value, F test, okay? Okay, next one is correlation analysis. Correlation analysis, the study of the relationship between variables. It is also defined as a group of techniques to measure the association between two variables. Okay, if there are two variables, something like temperature and ice cream demand. What do you think? Temperature increase probability ice cream demand increase, right?
Mhm.
So increase, maybe. So maybe there is relationship between temperature and ice cream. How about temperature and hot drink? Maybe temperature increase, hot drink decrease. Temperature decrease, hot drinks sales increase, right? Like this. Maybe, right? So, if there are two variables, and then find relationship. That is correlation analysis. Variables. Usually linear function like this. Then two variables y and x and y. We call this x variable as independent variable. Y variable is dependent variable. Usually x move, then y move. So x move independently depending on this x move, x variable, independent variable, y move. So y is dependent variable. Okay. And then on axis, usually vertical axis, y variable, dependent. Horizontal axis, x variable, independent variable. Okay, sales, call, and copiers sold. More sales call, maybe more copiers sold, right? Maybe there is relationship. Correlation coefficient, simply we read like this, R, denoted by R. A measure of the strength of the relationship between two variables. It shows the direction and strength of the linear relationship between two interval and ratios variables. R calculated by this formula. Then R value from -1 to +1. If 0, there is no relationship. If R closer to 1, +1, this direction, that means x increase, y increase, such as temperature and ice cream move together, same direction. If R equals closer to -1, then direction is like this. If x increase, y decrease, such as temperature and hot drink. So negative correlation, positive correlation. Closer to 1, strong, positive. Closer to -1, strong, negative correlation. About 0.5, there is relationship, but not much. Weak, positive, weak, negative. If R equals 0, scatter, then there is no direction, no relationship. Another, R equals 0, maybe there is something relationship, but not linear. Linear means straight line, right? Straight line. But something, there is line but curve. So this one is non-linear relationship, or we call that curve linear relationship. Or using this formula, then we can calculate something like this, and 0.759. I will show you. Look at the that's this one. Later I will show you. So R's coefficient determination, something like this, okay, by calculation using x minus x bar is mean, right? So add all x and then divide by 1, 2, 3, 4, n is 10, then x minus x bar, y minus y bar, divided by n minus 1 is 10, minus 1, 9, standard deviation of x, standard deviation of y, and so on.
And you can get those numbers from the, when you do the next.
Okay, I will show you. Our example here, that one is the sales call and copiers. Megastat and correlation and megastat, correlation and regression, and then correlation matrix. And this one asks input range, specify everything, specify everything, and then okay. Okay. This one 0.759. 0.759. This is R. So 0.759 positive, right? So positive, not very strong, but about strong. About
More
strong.
than 50.
Mm-hmm. Okay. Okay.
So like if we were to work this problem out manually,
Uh-huh.
how would we know that it's 9.189 and 14 point?
This one. If question using a hand calculation should be given or give you data, then using megastat descriptive statistics, then you can get standard deviation, right? Okay, good. And coefficient determination, R square. If we have R, then square, that is coefficient determination. R square is the proportion of the total variation in the dependent variable y that is explained or accounted for by the variation in the independent variable. Something. That means, okay, sales core, probably more copiers sold, right? Anyway, there is relationship, right? Then, how much? R is direction and then show a relationship, right? But R square, how much? Representative or explain. So, R square, this says dependent variable Y, copiers sold, explained by X variable, independent variable, sales core. So, more sales core, more copiers sold. So, how much it explained? That is R square. It moves from 0 to 1 because square, right? And then there is no direction. So, the coefficient of determination R square is 0.576. If R is 0.759, 0.576, that means copiers sold explained by sales core, how much? 57.6%. Something like this. 1 core, 2 cores, 3, 4, 5. If the simple example, core 100 make 100 cores, 57.6 explained. Just simply, okay? Just understand like that. So, core 100 times 57.6 times what?